Ladies and gentlemen of Algebra 2 Honors, welcome to class today. We'd like to especially welcome back Ben.
Yes, Ben.
And Riley.
Yeah, Riley.
So good to have everybody here today. We still got Jay out of here, but anyway, he'll get back. He may be gone for next week, this week. I don't know. Let's. What we're going to be doing is we're going to be starting on multiplying polynomials today, which is the next section in our book. And I'm going to start out by just giving a couple examples of those before we get to the exercises on them. But let's go to this first example. We have the example of a rectangular prism, which is a fancy title for a cube or a box, right? A cube is like a special case of a rectangular prism where length, width, and height are the same. Here we have a representation of a rectangular prism given by a length, and there's our length right here, by a width, and by a height. And so when we multiply all these together, we obtain a volume. Okay. So there are different techniques you can do to multiply polynomials together. The one that I like to use personally, and consequently most of my students, is something like this. This thing that I am now drawing is what you would call a window. It looks like a window. It does, yeah. Window, so it looks like a window. Yeah. Well, that's one way you can look at it. That's what it looks like. But this is what I call the box method of using distributive property of algebra. And so if we take this x plus 3 times x plus 2, and we put x plus 3 times x plus 2, and then we multiply the terms together in the space where they intersect. So you take a row times column, so x times x is x squared, 3 times x is 3x, 2 times x is 2x, and 2 times 3 is 6. And then usually when you multiply polynomials together like this, they will be arranged that you can combine terms kind of diagonal from each other. And so we can rewrite this volume as, with just length and width multiplied together, x squared, and then we have 2x plus 3x, which is 5x, and then we have plus 6. And then we still have this x outside here. And the last thing we can do is distribute the x to all the terms inside parentheses and get x to the third power plus 5x squared plus 6x. Okay, how's that? Is that pretty, does that make sense to you?
I think so.
Pretty good, okay, good. And so that's one thing we can do. In our exercise set we're going to go to in a few minutes, the very first problem is very similar to this box problem. So you'll be ready for that, I hope. Then we're given an example, example 1, perform the following polynomial multiplications, and here they explain how to work it out. One way you can do that is you can connect the terms like this. So x times each of these plus 2 times each of these, and add them together. So you'll have 6 terms total. The way I like to do this is, seeing that we have a binomial times a trinomial, I like to set up a box in a configuration like this with 2 rows and 3 columns, and up here above the columns we write each term of the trinomial. So I'm going to put 2x squared up here, and then minus 4x, and then finally we have plus 1, and then on the side we put x plus 2. And then same thing, multiply in the space together where they intersect. X times 2x squared is going to be 2x to the 3rd power. And x times negative 4x, negative 4x squared. 1 times x is x. And then here, and one thing you can do, if you say this is a number, and I know that's 2, I can just multiply each of these by 2. So this is going to be 4x squared minus 8x and 2 times 1. And then we have the diagonal orientation here. So our answer to this polynomial multiplication problem is 2x cubed, and then 4x squared minus 4x squared cancel out to be 0. And then we have negative 8x plus x. That's going to be negative 7x. And finally we have plus 2, which fortunately is the same thing that the book got in its answer here, right? Any questions on that? So we're going to go over some exercises now, and we're going to use our little friendly wheel of fortune, or maybe you call it the wheel of misfortune. Nobody laughed at the wheel of misfortune.
I'm sorry, I was kind of bummed out there.
It's okay. Well, Ben chuckled a little bit there. So
That's why, man.
Well, that's better. What's that, Mark? So go ahead and work out problem 1. I'm going to spin the wheel here in just a couple minutes.
Oh, you didn't tell what's my name.
Kathy, do you have a phone?
Okay, ready to spin for number one? Yes? No? Maybe?
Go for it.
Shuffle is-
Little margin.
Yeah, margin.
Good mark.
Okay, Marcus?
I read number 2 is about 1.
You did number two? You're saying you did number two, but not number one? Is that what you're saying, Marcus?
Okay. You make a box with 4 boxes inside of it.
So kind of like this?
Yeah, the window.
The window, yes.
And on the top you put X and then 5.
Okay,
And then you put X and 1.
X and one, okay.
And that will equal X squared, 5X, X, and 5.
Okay,
And it would equal X squared plus 6X plus 5.
okay. And you multiply that by X, is what you're saying? So what is this going to be here when you multiply everything by X?
X. Wait, how do you say 3?
Cubed, like a cube. X cubed, cube, that's how you say it. Okay, then what else?
6X squared, and then 5X.
Yeah, I got something different.
Did you? What'd you
I
get?
got some,
I got X squared plus 6, X plus 5.
yeah, that's what I want. Oh, we forgot to put the X.
What?
The X for the height. Or, that's what I did.
X plus 5 is times
I forgot to put the X and multiply.
Good. I'm glad you finally came back. Dude, I had Tostitos last night. Woo! Hey, we're rolling, Janet. Oh, I mean, it's 50, so you have to go now.
We're about ready to send out the cops, Jaden.
Yeah, I'm just like looking.
Mr. G, did you get a haircut?
A little scared.
Yes, I did, thank
Looks
you.
good, looks good.
Thank you, very, very good.
Fresh cut.
Mr. G, you should grow out your beard.
No,
What?
well, there are multiple reasons for that.
What are those reasons? Mr. G?
We don't need to go into that right now. I don't need to be held accountable by my students right now for that.
Mr. G,
Yeah,
you
we'll hold you
should,
accountable.
You can hold me accountable for other things, but
you
not
should
for
grow one of
that.
those long mustaches that go like down to your
Like
chin.
No, you need to get one of those things that like curls up like right here.
No, that's Italian. You gotta get one of those like Batman with
Okay, guys.
See it in his face.
Guys, let's bring it back. Are you doing number two now? Do
Yes.
number two, and then I will call somebody
Yes, we are.
in a minute.
I have no clue how to do number three.
Number three?
Yeah, number three has
Number three, 4,
Okay,
6, 7, those.
good. Well, you can do two, right?
Already done 2.
You have done two, okay. So do number two, and we'll get to it. We'll either get somebody to show you how to do, in the class, do number three, or I'll do it, or somebody.
I'll do it for you.
I've already done it.
Yeah.
Like I tried to
Okay.
do it, and I kind of just confused.
I'll learn how to do it real fast.
Okay, Marcus just asked a good question. Says, isn't like number three the same thing, but you just add extra cubes?
Yes.
Yeah,
Yeah.
pretty much
See, I
that's
tried to do
it.
that, and it just confused me.
Yeah, I can. We'll do that. And the idea is to work out a process, a system whereby you're not as confused and you're on the right track, confident that you're doing it right.
There's only one thing I'm confused on.
I'll give it another shot.
Yeah, That's the spirit. That's,
Not really the spirit.
Okay, well, I guess I did Yeah, I'm voting for.
Yeah, Mr. G. You still have to, like, if it has x2, you can't add the 3x to the x2, you have to add it to the other 3x, or multiply it to the...
yeah, you gotta do it. I'm gonna use the box method up here, but whatever way you do it, it's fine. A student from
What is negative 4 and 9?
from 7th period, Victoria.
5.
5.
She didn't use the box method, which is okay.
It's not 7.
Multiply
Please stop
2
talking.
with
I'm
the,
trying to focus. Stop, stop.
with the power of whatever, like.
Hey, you remember Caden Goodall?
You do x to
That's
the
Eddie
power of
Woodard.
2 and
Addy, you like Caden Goodall?
3x to the power of 2, would it be?
We all played baseball together.
That'd be 3x to the power 4, yeah.
Okay.
He's actually pretty good now.
Is he? He was the catcher, wasn't he?
You were.
I know that, but before.
Remember Nate?
I hate
So it wouldn't be 4.
No, before I
So
think
did
he
you
was
do
the
it?
catcher.
No, because you're multiplying.
Yeah.
Never
I
mind.
haven't been there.
Well, he came there while you, he came
That one?
when you came. Like, you were before him, I thought.
No, I remember him being there.
Okay,
Oh,
you're
you
working
have
on this, right, Jade?
Plus
Yeah,
5x
yeah.
squared minus
I
9.
think I figured.
We'll talk
You got
about
it,
it later.
Cole?
Okay.
You got it, Kim?
Yes.
Okay, let me give you another minute of latency before we spin.
Trust her.
I don't like using the box method. I don't know why, it's just confusing me.
Yeah, some people are like that. Most people not as much, but some are. Like you'd be like Victoria's 7th period was similar to what you're saying.
Okay, I think I figured it out.
All right, let's go ahead and spin this right now.
Are you serious? Oh my gosh, the one time.
This is easy.
Jen, you can talk us through it. There you go.
So what I did first is I took the, like, you know how you do the distribute the parentheses into the other parentheses, so it's just one parenthesis?
Yeah,
I took 3x and multiplied it times 3x. Right?
like
Yeah, like
this.
that. Yeah. And then I got 9x. And then you would put the 2x squared in front of the 9x because it's higher, it's to the power of 2.
So put 2x squared over here.
Yeah. I don't even know if I'm doing this right. Plus 9. Yeah, right there, okay. And then I took the negative 2 and I multiplied it with the negative 1 and got positive 2. What I do? Right? And then that's where I'm at right now.
I'm not seeing it.
Well, the thing about it is I don't see this thing is not a thing at all, right?
It's not?
Yeah, I have my desk.
Now, if we continue what Jane was saying, okay, if we took 3x and multiplied it also by this,
Oh, okay.
and also by this,
And
Yeah,
and we
the
took
Okay.
2 times that, negative 2 times that, and 2 times that.
Gotcha.
Now we would be in business, right?
Okay, that's what I didn't do. I
Okay.
was just testing you, Mr. D.
No, that's fine. That's part of what.
Exactly what I did.
why are
Now,
you erasing? She just added.
huh?
What?
I wrote something
Well-
on here that I didn't want on here anymore.
Oh.
Yeah, I spelled my name wrong.
Did you spell your name wrong? Jen?
This one here, I think he was, no, because he was 3x times 3x, so So these two things are good for what he put down, right? But he needs to put 4 other terms besides those, right?
Yeah.
So what are the other, so Jade, what are the other terms you're gonna list
It would be
besides these?
9x. It would be 6x squared,
So 6x squared,
right? And then it would be negative 3x. And then it would be 2 times 2 would be negative 4x squared. And then 2 times 3 would be negative 6x.
so that's 6 of them, is that all of them?
No, we need one more.
Well, there's only
Oh, never mind,
6
you already got the
possible,
2.
right?
Never mind, we already got the 2. So yeah, but that's all of them.
So if we simplify all this, what do we get?
Seems like a lot. I feel like I did this wrong. It's a lot of work. If you simplify it, like that's all one equation. That's not all one equation. So yeah, I'm really lost right now.
It's easy if you do the
It's easy
square
to do the
thing,
box.
yeah.
Yeah, let's start over and you teach me how to do the what?
Box.
Yeah, the box.
The window.
Because I was looking at Bryce's paper and he has like 3 squares and it was tripping me out.
Yeah, looking at Bryce's paper can sometimes be intimidating.
Bryce is quite intimidating.
Okay, so now you got 2x squared plus 3x minus 1 and 3x minus 2. And so now we have here 6x cubed.
And then 3 times 3 would be 9x squared. Then 3 times negative 1 would be negative 3x. Then negative 4x squared. 9x squared. Or, yeah. Wait, no. Negative 6x. And then negative, or 2, yeah.
So now you kind of look at it, what we had here. So these things are there, then these are okay, except that's supposed to be squared, and this is supposed to be cubed. So this right here, as presently constituted, are the same thing as this. But doing it like this just naturally sets these things up in this kind of pattern here, where we have 6x cubed, and then negative 4x squared plus 9x squared is going to be plus 5x squared. And then negative 6 minus 3 is going to be minus 9x. And finally we have plus 2. Anybody get something different than that? Is that what you got?
That's right.
That's what it makes
Yeah, that's
sense.
what I get.
That's what you got?
Did y'all distribute like I distributed? Or did y'all just plug them all in?
We did it all.
We in the box, because we are super smart, you know.
Gary?
If you're, oh, you already, I'm trying, so I'm not sure if
So like on number 3, Mr. G,
Yeah.
we would put, it would be a 3x3 box?
Yeah, you make a
Okay.
3x3 box.
Okay. See, that's what was confusing me. That's why I didn't know, like I didn't know how to tell.
And see, that's one reason I like the box method, because it has flexibility
Yeah.
between different arrays of variables. All right?
So, did you combine like this big thing? With that? And then the negative 2 and 18. And then, would you you do the negative 6 and 3?
I think that's what I did.
That's it.
18. Anybody else have 18x?
Oh, you just add this to your
18x. Huh? For the cube?
I think that's how it's.
Yeah, I got 3x5.
You're
Is
asking
that
on the
wrong?
first
3x plus 15x plus 16x cubed.
My immediate judgment on that
3x squared.
is going to be based on a limited remembrance from prior classes.
Is that okay? 3x squared.
So,
The 3 and I did 4.
Huh?
3 weirded me out to do.
How much is 5?
Well,
I did not get 5.
Why are you on 5? We're on number 3.
What did you get? Just the x squared. On number 3.
yeah, number 3 made me uncomfortable, made me doubt.
Negative?
So,
15x squared plus.
Oh yeah, I put plus. And then plus 6x minus. I put minus instead of, I mean plus instead of minus. I think I did. I hope that's right.
yeah.
I hope it is, if not,
Okay, here we go. Number 3.
there's a lot.
Number 5 also made me doubt.
Yeah, we may not get to 5 today. We may just get through 4 today, all right? All right. Let's get to our wheel of misfortune.
Wheel of despair.
Wheel of despair. Kind of like that. Wheel of despair, wheel of misfortune. Gabby, Bryce, Gabby, Bryce. 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 All right, Bryce, what do we got?
Put it all in a box first, like, put the.
Like this?
Yeah. 3 by 3.
Now, for 7th period, I had somebody else who made up a new name for this one, not a window.
Oh, that's a
X, X, X. Oh, yeah, tic-tac-toe.
Isn't that the front of a truck?
He called it a waffle.
Oh, it is a waffle, now that I think about it.
Lego my ego.
I think it was, I think it was Chris who came up with that. Anyway, let's go, or maybe it was Luke, I don't know.
Can we do the waffle method?
All right, so go ahead, Bryce.
Then I put the 3x2 on top, 3x squared. Plus 6x, that's positive 6x. And then the negative 2.
Okay.
And then x cubed, 3x squared, and then positive 1.
Okay.
And then I multiplied the 2 together, and I got 4x, right? 4x.
These two multiplied together?
Yeah. 4x to the 5th, right? Is that right? Or do I need to multiply the...
This is what I got for it,
Okay.
3x to the 5th.
So you don't use the... Oh, how would I do the 3x5, and then multiplied the 6x, 3x, and got 6x to the 3rd, right? 4. And then the negative 2 and x cubed is negative 2x. So, and then I got 6x to the 4th.
Bryce, 6x to the fourth, Bryce, you sure about that?
9x
Yeah,
to the
no.
fourth, my bad. And then 12x to the third. No, 18x to the third. And then negative 6x to the second, or squared.
Okay.
And then 3x squared. 6x. And negative 2.
Okay. And can we write down an answer out of this thing yet?
Yes.
Thank you, Bryce. Okay, what do we got here, Bryce?
15x to the fourth, right? Or no, 3x 5, then 15x to the fourth. And then 19 to the... Wait.
Now this one here is a little more confusing because because you have x, you're missing a term here. And so it kind of puts the diagonal relationship out of kilter. Okay, what next?
And then 3x squared, right? Negative 3x squared. And then 6x and then negative 2.
Okay, does that look right?
Yes.
Yeah, it looks right. Okay, what I want you to do is work out number 4. And I'll call somebody in just a minute for number 4. We'll probably just have to finish with that today, with number 4 today. How's that sound? Then we come back, sleep on it, come back tomorrow, and maybe we'll come back tomorrow with a little more clarity on this thing. All right? Okay. Here we go. We are to the wheel of despair. The wheel of despair and discouragement and desolation. Okay, let's yes. That's what she gets. That's the reward you get at the wheel of despair. Yeah. Yeah, we'll get you for that one, right, Abigail? All right.
Yeah, I guess so.
All right, let's go ahead. But she fortunately has worked this one out, right?
Yeah. So I did the waffle.
The waffle, the 3
And I
by 3
did
waffle.
down the side, x squared, 9x, 7. Okay.
So x squared, 9x,
Now let me double check, make sure that is the 2. Yeah.
7 down here. Okay, and then up here.
And then up at the top I did 3x squared, 9x, and 5.
Okay,
And that gave me 3x to the power of 4, 9x to the power of 3, 5x squared, and 27x to the power of 3,
so I said x to the 3, okay.
81x to the power of 2, and 45x, and then 21x to the power of 2, 63x, and 35.
Okay, and that's going to be,
And then I got 3x to the power of 4 plus 36x to the power of 3 plus 107x to the power of 2 plus 108x plus 35.
That's 107, right? Plus 108x, you said,
108x plus 35.
plus 35. So it's going to be all this here, right? So we're going
A lot of
to,
big numbers.
yeah, a lot of big numbers. Did you use your calculator for that?
Yeah.
A little bit? Yeah. Yeah, other class.
My brain just wasn't working.
Yeah, that's right. And it's not like they're super big numbers, but still, yeah.
Yeah, they're not super big numbers, it's just, sometimes just, after a